Okay, so for question number 2, we're asked to find one of the sides of a right triangle given um, that we know the size of one of the acute angles. So you can see in the first problem, we're given that this acute angle is 68 degrees. And I'm going to go ahead and highlight the sides that touch this angle. One of the sides is the hypotenuse, and the other one that's right now touching that angle is, of course, the adjacent side. So you can see I'm asked to find the length of B, which is the adjacent side. I'm going to go ahead and label this ADJ. And over here I've got the hypotenuse, HYP. So the trig ratio that I'm going to use that involves both the hypotenuse and the adjacent is the cosine ratio. So our equation is actually just going to be the cosine of that 68 degree angle, those are measured in degrees, equals the length of the adjacent side, which is B adjacent, over the hypotenuse, which is 17.3. To solve that equation, it's fairly straightforward, right? I've got a number equals a variable over a number. So I'm just going to multiply both sides by 17.3. If I was to multiply this side by 17.3, you can see it would create a giant 1 with the 17.3 that sits below, and I would be able to eliminate that. So let's also multiply the other side by 17.3. So this becomes 17.3 times the cosine of 68 degrees, and that is exactly what B equals. Let's go ahead and evaluate that using our graphing calculators. It's a good idea to double check and make sure you are in degree mode. So I'm going to press the mode button, and you can see degrees is highlighted, not radians. So we're good to go. I'm going to go ahead and press second quit, and I'll just enter 17 and then 0.3. Whoops, not negative, 17.3, and then times the cosine of 68. And again, since I'm in degree mode, my calculator is assuming that this angle I'm entering is given in degrees. So when I press enter, I get 6.4806, and I think that it says to round your answer to 1 decimal place. So I'm going to round this to 6.5. So our answer is 6.5 units. I don't know what these are. I don't know if they're feet or inches, but I do know they're linear units. So 6.5 units. The next question, let's see. This is the angle I'm talking about. It's up here. It's a very tiny angle, 10 degrees. This is clearly not drawn to scale. So if I was to sketch this out, you can see this time I'm given the length of the opposite side. So I'll label this. It's OPP. It's the one that's across from the angle. And I also have the adjacent side, ADJ. So the trig ratio that deals with opposite and adjacent is the tangent ratio. So we'll go ahead and write that down. The tangent of this tiny little 10-degree angle is equal to the opposite side, which is 7.4. Whoops, I was going to write 5. 7.4 divided by m. So I've got my variable in the denominator, and there's an opportunity for errors to be made here when this happens. So a lot of times we might end up just getting the reciprocal of our variable, but we want to know what m is. So I'm going to multiply both sides by m. So I'll write m times the tangent of this 10-degree angle, and that is 7.4. Very straightforward. I had equal things. I multiplied both sides by m, and I get equal things. So this is equivalent to the previous equation. And then real simply, if I divide both sides by the tangent of 10, I get m. So m, in fact, I can just write this down here. Well, no, I want a number there. So I'll write m is equal to 7.4 divided by the tangent of this 10-degree angle. So let's go ahead and grab our calculator. I will enter 7.4, and I will divide that by the tangent of 10 degrees. And when I do that, I get what I think is a very large number, right? I get that it's about 40, and let's see if I round to the nearest. Let's see, it says round to 1 unit. So if I do that, this 6 is going to trigger the 9 to round up. So this will actually round up to 42, and then I include the 0.0 to indicate that I am rounding to 1 decimal place. So if you look at that in slow motion, right? 0.96. I'm rounding to this decimal place. This 6 indicates that I should round up, so this becomes a 10, right? And it brings another 1 up here. So this is, we're writing down as about 42, and these are units. 42 units. And again, you can see that this is clearly not drawn to scale. That's such a tiny angle. This is really a very, very tall, skinny triangle, right? And this M is 42 units long. All right, and then our final question for question 2 is part C. It's in this triangle, we are given this acute angle up at top that has a measurement of 21 degrees. And we are asked to find the length of the hypotenuse, right? Here's HYP. And we're given the length of the opposite side, OPP. And that is, of course, when we would use the sine ratio, right? Sine is opposite over hypotenuse. So we'll go ahead and write that down, right? The sine of our 21 degree angle is the length of the opposite side, 99.8, divided by x. Okay, so same thing popped up here. Again, I'm going to multiply both sides by x, so x times the sine of 21 degrees, and that equals 99.8. And if I divide both sides by the sine of 21, now I can write this expression that represents what x is. X is 99.8 divided by the sine of 21 degrees, and this will be pretty straightforward to find, right? So I'm just going to grab my calculator again. Clear it, and I'm going to enter the 99.8, divide that by the sine, and this time it's a 21 degree angle. And when I do that, I get an incredibly, that's very large, right? That's a very large hypotenuse. I get one of, and again, I'm rounding this to the nearest tenth, or to the nearest, to 1 decimal place. So this time it will be 278, and maybe you can guess it. It's going to be 0.5, and these are units. 278.5. All right, so that's all of question 3. Again, in this question, we were given an acute angle and a right triangle, given one of the sides, and it could have been a leg or a hypotenuse, and we were asked to find a missing side. Let's move on to question 3.